Hello, I'm Filip, and I'm a senior Kotlin developer at TouchLab. Before we begin, let me share a bit about my background as it's relevant to today's talk. You may know me as a co-author of Sky, which is a Kotlin compile and also Gradle plugin for Kotlin multi-platform. What it does is it improves the interoperability between Kotlin and Swift. But other than that, I spent my whole developer career working as at small mobile developer agencies, building mobile apps for other companies. Naturally, to that work, I got to wear many different hats, basically different for every single project. And that frequently involved having to deal with build scripts and build setups of those projects in various different build systems, most notably Gradle. My journey with Gradle began many years back when the only way to use Gradle was using Groovy DSL. And I have to admit that back then I was completely lost. I had zero idea what I'm doing. Whenever I had to deal with a problem or have to change something, I went to Stack Overflow looking for an answer, copying that back to the project, hoping it works. Things changed a lot with Kotlin DSL because suddenly things became static. The IDE was able to help providing documentation, code completion, and in general, things became more predictable. But still, it took me a while to finally get fed up with the way I was working, and I said, okay, for me to do my job well, I have to learn more. I have to understand the basics. So I decided to dedicate a significant amount of time and learning Gradle by systematically going through its documentation page by page. And over time, this unlocked a lot for me in terms of Gradle. And then another change came when I was forced to write my first Gradle plugin and subsequent plugins, as that gave me the perspective of the other side, of the library authors or plugin authors, what problems they have to solve and how are they solving them. As many plugins in Gradle work similarly, and once that happened, I started seeing the same patterns over and again, and things finally came together and started making sense. This brings me to the reason why this talk even exists. My idea for it is to share with you the few aha moments that I had throughout my journey, point out the things that confused me and that helped me to learn Gradle once I understood them. We will start with answering a seemingly uninteresting question: what is Gradle? This question on its own hides a very important insight. Then we will cover some of the basic fundamental building blocks of Gradle. Though I should warn you, we are just skimming the surface. The Gradle is too large, too complex to cover in a single talk, maybe in a single day. So today I will focus only on the stuff that I found confusing and I see people getting confused by a lot. And at the end, I will teach you how you can debug Gradle scripts, because I think this is a very valuable skill to have when having to change Gradle, having to deal with issues. Okay, so what is Gradle? Gradle is a build system, but more importantly, you have to see it just as a platform. On its own, Gradle doesn't know much. It doesn't even know how to build your project. All of that comes from plugins. The reason why Gradle exists is to provide common functionality, common features that are used over and over again when building projects of any kind, of any language that you can imagine. Gradle provides those features for the plugins so that the plugin authors don't have to reinvent the wheel over and over again. Gradle gets a lot of bad reputation for being complex, difficult to use, hard to learn, all of that. My argument is that not all of that is a fault of Gradle. Some of it is inherent to what Gradle tries to achieve. Gradle tries to be flexible, extensible, something you can build upon. And while people commonly want to use something that's simple, a simple build system that can just work on their project, I've had to work with those as well. And in my experience, the simplicity has its problems too. For a simple small project, sure, there are use cases where that would help. That more realistic projects, the larger they get, the more you will run into limitations of the simpler build systems. And in my experience, having to deal with a build system which doesn't allow you to do what you want or need to do can be much more frustrating than having to work with one that does, or it comes at additional complexity as a result. Speaking of complexity, plugins. In my opinion, what people complain the most about Gradle isn't actually Gradle. It's just the plugins that they use in Gradle. Most notably, the Android Gradle plugin, though the Kotlin multi-platform plugin also shares some of that blame. It's the plugins that add a lot of the functionality, and sometimes even the plugin authors contribute to accidental complexity of your builds. Plugins add a lot. We will cover some of those things. For example, plugins add extensions to your builds. Extension is a concept in Gradle that allows the plugin authors to give you as a user a way to configure your builds or configure the plugin's behavior using an API that's usually should be easy to use, not always. The point is the extensions define DSL. You will see these extensions all over the place. For example, here we have like this Kotlin block at the top of the file, or like top level function. Everything inside it is from the Kotlin Gradle plugin. Similarly for the Android one. In general, like there is a convention that the name of the extension is somewhat related to the name of the plugin, but that's not necessarily a hard rule. I mention this because this brings us to the that you have to make an important distinction when you are dealing with Gradle about what is Gradle itself and what is coming from the plugins. Sometimes you want to know like what, for example, this piece of code does. As I mentioned, this is from the Kotlin Gradle plugin. For that answer, you have to go to the Kotlin Gradle plugin documentation, which is owned by JetBrains, not by Gradle. If you were trying to look for this answer in the Gradle documentation, you will not find it. The same goes for Android. Similarly, if you are dealing with issues, understanding and being able to narrow down who is responsible for that issue will help you ask the right question in the right place for the right community. Similarly, when reporting bugs, Gradle gets so many bug reports about stuff that aren't Gradle at all and are in fact problems of the given plugin. By narrowing it down and asking the correct question at the right place, you are significantly increasing your chance that you get the right answer. Another thing that is added by plugins are the tasks. You've all run into tasks. That's what does all the work in Gradle. If you are syncing your project or clicking the run button in IDEA, or from terminal, you will just see this list of tasks written down by Gradle as they get executed. This is exactly it. Gradle defines tasks as an independent unit of work, which is a fancy name of saying that there is somewhere in the code a function with some logic in it that does a thing that ideally should be independent of other such functions. There are many different types of tasks. Some of them compile code, some of them run tests, publish artifacts. More generally, they transform files. If we abstract that even more, we can say that tasks take some inputs and they convert them into some outputs. Usually, those are files, because most things that Gradle does somehow involves files and file system. As such, Gradle has many APIs that improve the way you can use file system from Java on top of the existing Java file APIs. A significant feature of tasks is that they can be chained together to create a more complex thing. You can use outputs of one task as inputs of another, which is why in Gradle, the inputs and outputs, they aren't just an abstract concept. They are fundamental feature of task that you actually have to explicitly define to form the dependencies correctly. You can think about all of that as, for example, in Bash or like any other shell, Unix shell, where you have commands, and there is sort of like unwritten rule that commands should do one thing and one thing well. And if you need something more complex, combine them together using the pipe character. Tasks, that's exactly the same thing. Now that we have tasks, we can look at the build lifecycle. This is one of those things that confused me at the beginning quite significantly. The concept is simple on paper. Gradle doesn't run all the code that you have at once. There is an order in which it gets executed. And more importantly, not all code gets executed during every single build. Gradle has three main phases. Those have like steps, what happens during them, but some plugins like the Android one or Kotlin multi-platform one adds their own lifecycle as well on top of this. The first phase is the initialization phase, during which Gradle looks at the settings Gradle KTS file, and in it there are like basic information needed to understanding the build in general. Most importantly, there you declare your modules. Gradle calls them projects. This is the include function. After that, Gradle now knows which modules are part of the build, where they are located, where are their build Gradle KTS configuration files. At the beginning of the configuration phase, Gradle looks at those files and extracts the plugins block that we've seen before. This block has a special treatment in Gradle, and it's used to tell that it allows you to tell Gradle which plugins you need to add to the build. Gradle does that. It initializes the plugins. There is like a special function for that in the plugins. After all the plugins are initialized, Gradle takes the rest of this configuration file and executes it top to bottom. After your configuration file is executed, the plugins can do other stuff. That's the famous after evaluate function. Result of all of this configuration is a task graph, which is a structure that contains the task that will be executed later on. Therefore, not all tasks are part of this, just the ones that need to be executed. And it's a graph because there are dependencies between the tasks that form the edges. Gradle now takes this and moves to the execution phase, and this is the time where the tasks are actually run. The Gradle executes them one by one in the correct order. Sometimes it can run them in parallel if they are independent. Somewhat unrelated to this is a dependency management, but still worth mentioning. In Gradle, dependency management is a bit more abstract concept than in some other package managers. In Gradle, in general, these just provide resources to your project, whatever those resources are. Most commonly, it will be jars or klibs for Kotlin multi-platform, or even just binary files for native language. Gradle also uses the same infrastructure for managing plugins. That's why you see a lot of the same looking APIs in a separate place where it's about plugins and somewhere else where it's about the regular dependencies. But you can also use it to depend on real source code or any other kind of file as long as it's a file. Worth mentioning is that in Gradle, most of it depends on Maven. Gradle is really built on top of Maven in this area, and it just adds a bunch of additional functionality to it. And I should warn you that, in my opinion, the dependency management in Gradle is one of the most, if not the most complex part that you can run into. Not necessarily a fault of Gradle, it's just that dependency management as a problem is surprisingly complex, and the more you dive deep into this topic, the crazier it gets. Now, if you've ever worked on a project that's sufficiently complex and sufficiently large, you've experienced probably that Gradle builds can take a while, which is kind of a problem for a build system whose job is to build your project as fast as possible. Obviously, the authors of Gradle are aware of this, and as such, they added many optimization features into Gradle. I'm listing those most important ones here because they have a direct impact on how you use Gradle and how you interact with it. First one is Gradle daemon. Gradle is written in Java, partially in Kotlin, so it's a JVM program. As such, it shares many of the downsides or problems of JVM programs, namely slow startups. That's a problem for a build system who you usually use in a way that you just start a command it should do something and then terminate. And sometimes this can be like quite quick, like not all builds take an hour. So the overhead of the JVM startup can be very significant. Similarly, there is also JIT, which takes a while to kick in and optimize the code, and it takes a while for JIT to pay for itself because you have to spend extra time compiling the code at runtime. The solution to this is a thing called a Gradle daemon. Daemons are a common pattern in the JVM ecosystem. For example, the Kotlin compiler also has its own daemon. It's the same concept. And the daemon is just a background process, or you can think of it as a server that runs for a very long time, and it's what actually executes your build. When you interact with Gradle through command line or through IDE, what happens underneath it is just that this is like a front end that sends the command to the server. You might have noticed this, for example, after you restarted your computer, that the first build usually takes forever. That's exactly the reason why. Another feature that is very nice is the incremental builds optimization. This is a concept that allows Gradle to skip tasks if they are not needed. Because during builds, you oftentimes run the same task over and over again. In many cases, you don't change anything. You didn't change the inputs, and therefore the outputs should theoretically be the same. As such, Gradle can just take the outputs that are already on the disk and not do anything with it. This is what you see as the famous up-to-date message next to your tasks. Building on top of that is the build cache. The idea is very simple. Why do we have to repeat the same work if the outputs of the task didn't change? By the way, this is why in Gradle there is a rule that if you have a task, it shouldn't modify files in place. It instead should take inputs that are in one location on the disk, change them, and write those outputs to a different location that is owned by the task. The build cache builds on this idea, but it allows Gradle to store those files outside of the project so that they are not necessarily invalidated if you make a change that you then later revert. This way, Gradle can reuse outputs of tasks from many past builds. And it's not just the time, it's also the space, because now you can use this build cache that is shared across multiple machines using a remote build cache, which is particularly useful during like CI builds. This is a feature that has some downsides. For example, the extra space on disk that you have to allocate to it, therefore it needs to be manually enabled. A concept that's built on top of that is the so-called configuration cache. So far, we were optimizing the execution of the tasks. But one other thing that doesn't change much is the configuration itself. Like you will run many builds before you touch your build scripts. So if Gradle can cache that configuration, it can skip everything that's happened before the task execution itself. This is most noticeable when the build or the task execution itself takes very little time, and the build time total is dominated by the time of the configuration phase. Like what happens when all of the previous optimizations work together. In this case, just enabling the configuration cache, like cut the build by like 100 milliseconds, which doesn't seem like much, but it's something that's noticeable, like in terms of responsiveness of the system. And more importantly, this is an empty project that I created for this demo. Real projects, the configuration in them takes way longer than that. But the configuration cache has also other side effects, because it puts certain restrictions on how you can configure your builds. One of the advantage of Gradle is that you can write it in like Kotlin, like regular Kotlin program. Therefore, you can do basically anything. But being able to do basically anything has its downside that now the tooling has no way to reason about what you are doing. By putting certain restrictions, Gradle can perform certain optimizations, like for example, execute tasks in parallel from the same module. Whereas before, without this, it can do that only for tasks that are in different modules. And in many cases, the way the build works, oftentimes you are stuck in the same module, and therefore this prioritization is sometimes even more beneficial than just the cache itself. And because this requires you to sometimes change your build or plugins for this to support it, it also needs to be manually enabled. And the last optimization that I have here, which is likely the most intrusive one in terms of how much it affects the way you write your build scripts, is the lazy configuration. Whenever you have a computation that's kind of expensive to do, but you don't know if you actually need its output or not. There is a common pattern for solving such a problem in computer science, it's not just Kotlin and Gradle, that you delay this computation for as long as possible, potentially forever. In Kotlin, you can use this lazy function to achieve exactly that. Gradle has its own API for it, it's called the provider. Underneath the same concept, it's just that the provider has additional functionality that it offers for Gradle to be able to do other things. And for you as well, because, for example, these providers have additional APIs. In this case, it allows you to make a transformation of the value stored inside the provider without evaluating the provider itself, like you do, for example, with sequences in Java. How to use such a provider? In the past, this is how you would configure your plugin. The plugin has an extension, there is a property, and you would set a value of this property to the result of this function. But we don't want to do that because now we are computing it immediately, and maybe nobody even requests the value of the property. New API adds a second version of this function that accepts the provider. And this is why I call this the most intrusive feature, because now many Gradle APIs have these dual versions. One of them is eager, one of them is lazy. In our case, we store the value in the provider, and this function will get only if someone requests the property. This needs to be combined with lazy configuration of tasks, because most often you need these properties for the task configuration. In the past, you would see tasks being created using this API, for example. The problem with this API is that it's eager, meaning the Gradle will immediately create the task and run your configuration, which can be expensive. But what is expensive is relative, because there are so many tasks in Gradle, and only a few of them or a fraction of them will get executed in a single build, so that the configuration of the rest of them is just meaningless. Therefore, even if the configuration of single task is cheap, it quickly adds up. So instead of this, we want to use a newer API called the register function, which does basically the same as the previous one, except it more or less wraps the previous one in the provider. And in fact, this function doesn't return a task, it returns a provider of the task. And Gradle will run the configuration block only when someone instantiates or requests value from the provider. Now, here is a very common mistake that I see in basically every single project I open, and that's when people try to configure tasks. This is an old API, and what it does is that it looks at all the tasks that exist, that are created, registered, filters them by type, filters out every task that is Kotlin compile. Think of it as filter is instance in Kotlin. And then it runs this configuration block on it. Issue with this is that this is eager. The configuration will get run immediately. But what's even worse is that this will instantiate a task. Meaning if someone else did something expensive to configure a task, suddenly everything gets evaluated at once. Meaning you basically negated the whole register thing and everyone's else work that they try to preserve the laziness of the evaluation by writing something like this. The correct way to do this is to use the configure each function. You might ask, why do we have to write an extra function to do the things correctly? And I should maybe mention that the other version can be correct in like a few small edge cases where you actually know what you are doing, but in vast majority of cases, this is the correct way. The reason for why we have a more complex API is that this lazy configuration didn't exist when Gradle was created. And back at the time they decided to add it, there was always so much code using Gradle that breaking all the APIs wasn't feasible. In general, and it's like an unfortunate reality of Gradle, whenever you see functions that do almost the same thing, the weirder one is usually the one that you want to use, because the weirder one was added later on to solve a problem of the previous one. So that's why we have an extra configure each. That's why we have a configure, why we have register instead of create. And with that, let's look at how you can debug your build scripts. The important message here is that Gradle isn't a black box. You shouldn't treat it as one. Like any other program that runs on your computer, someone had to write that program. Therefore, there is a source code for the program that someone likely had to debug the program at some point, so there is a way to debug it. The only problem is that we need a source code. Theoretically, you can debug programs without source code, but it's on a completely different level of complexity. Luckily for us, Gradle is open source, so we can get the source code. And this also shows you why it's so beneficial to work in an environment and ecosystem which is built on open source. It makes debugging issues much easier. I mentioned that Gradle is basically a JVM program, therefore debugging works more or less the same as for regular JVM code, though there are a few caveats. And I shouldn't say just a few. The purpose of this segment is to show you the ones that you have to be aware of. First, you need to make sure that IDEA will try to debug your Gradle scripts. For that, you need to go into the run configuration settings in IDEA, choose the configuration that you want to use, click on the modify options, and then there is a checkbox called debug Gradle scripts, and you have to have that enabled. Usually it is for Gradle tasks, but I don't trust these defaults. It's always better to check. This is the checkbox. And after we have that, now IDEA will theoretically stop at breakpoints that you put in your build scripts. But for that to be quite useful, we also need to attach sources of Gradle. There are a few ways to do that. One of them is to go to the Gradle wrapper properties file. In there, you usually change the version when you want to update your Gradle version. We don't want to do that here. We instead want to change the suffix of the version from bin to all. That way, when you refresh the wrapper, Gradle will download not just the binaries, but also the sources with them. But as I mentioned, Gradle isn't everything. Most of the stuff that we are interested in is from plugins. And chances are you want to debug stuff from the plugins, not from Gradle itself. So for example, here, if we want to go inside this Kotlin extension, we can go click on like go to declaration, and IDEA will open a file that looks like this, which is just IDEA telling us that it doesn't have the source code. Usually, for third-party libraries, you would click on the download sources button, but for whatever reason, this doesn't work, at least on my machine with newest IDEA version, and it was that case for a while. For whatever reason, IDEA treats Gradle plugins differently to how it treats regular dependencies, even though Gradle uses a lot of the same code for them. There is a workaround. Actually, you can attach the sources manually if you want, but in my case, I found that it's easier to locate the Maven coordinates for the plugin dependency. Because the plugins are regular JVM jars stored in Maven with some additional Gradle metadata. Now, once we have the path, or like once we know the absolute path where the class file is located, we can deduce the module coordinates from its path, because Gradle stores the class files in a particular way. In our case, for the Kotlin Gradle plugin, these are our coordinates. We take those and we put them as a dependency in either a dummy module that we created or in our existing module using a configuration like this function that doesn't impact the build in a way that we don't want to, and of course then it's better to remove it altogether. After we do this, we can resync the project and open the declaration again. Depending on your IDEA configuration, IDEA will not download the sources automatically. You can enable it, but by default it doesn't. Now you can click on the download sources button though, and hopefully, and I say hopefully because it took me like 15 minutes to convince IDEA to work for when I prepared this talk, you will see the source files. In my case, I had to close the file, open it again, resync the project, invite indices, then restart IDEA, and then it worked, but hopefully you will have a better time than me. Okay, we have sources, great. Now you can put breakpoints inside it like for any other regular Kotlin code, it will work. But there is one thing to be aware of. If you are debugging build scripts and your project has multiple modules. To demonstrate this problem, I've created a project with 2 modules, and in the first build Gradle file, I've added this function that we want to debug with a debugger. Now we can attach the debugger and start debugging. And we will run into a very weird issue, most likely. IDEA decides to stop in the wrong file. There is no breakpoint, nothing. And like what? If we look closely, we will notice that the debugger stopped at the same line as what we had in the previous file. And if you look even closer, we will see that the stack trace says we are in the foo function and that there is a local variable called a, which don't exist in the file where the debugger stopped. What's going on? The issue is that IDEA or the debugger as well handle debugging in a specific way. It locates the source code based on the fully qualified name of the class in that file. We don't have classes here, but what happens is that the compiler converts these build Gradle KTS files into a class that's named after the file. In our case, the class will be named build Gradle. And there is no package. It just sits on the top level. So we have, as a result, 2 classes that have the same fully qualified name with 2 different files, and the debugger doesn't know which one is the correct one. You will actually see this problem manifesting in a different way. Sometimes it's really coin toss. Sometimes the debugger actually stops in the wrong file. The stack trace and all of that will show the content from the other file, and you then can press resume, and the debugger will stop for a second time in the correct file. If you have 10 of them, well, then you have to go through 10 of them. There is a solution, fortunately. We can change the name of the class. We can rename our files to do so, and by doing so, we unfortunately create a different problem. Gradle works by conventions. That convention dictates that the file that configures Gradle should be called build Gradle KTS. We've changed that, so now Gradle is confused. Fortunately, Gradle is flexible enough that you can change that convention. You can go to your settings Gradle KTS file and write this code, and this will tell Gradle where to look for the given file. After you do that, and you resync your project, suddenly the debugger starts working again. But it's not all, of course. There are also a few Gradle features which will impact the build, or like the debugging experience. The first one is the Gradle daemon. If you are like me and you have multiple projects open at once, or if you are debugging something and you want to check if your change worked, you likely press the sync button in IDEA or just run some other tasks to confirm. And if you forget to stop your debugging session, you will be welcomed with this error after exactly 1 minute of the build doing nothing. The problem is that when you start debugging, you are actually attaching debugger to the daemon process. And when you stop in it, you stop the whole daemon. So when the front end then tries to connect to the daemon and sends it the next command for building, it will wait for the minute to connect and it will say, well, I can't. So it gave up and throw this error. Solutions are including disabling daemon, though I personally just unpause the build, which is it's usually the easiest solution around this, but I always forget anyway. Then incremental builds. When you are debugging tasks themselves, you oftentimes need to run the same build multiple times because you, for example, forgot to put a breakpoint in your code. The issue with that is that now when you run it for a second time, the inputs didn't change, the outputs didn't change, and Gradle can just skip the task. So you are not debugging anything. There are multiple ways around that. You can use the rerun tasks argument that you can pass to Gradle when you are starting the build. Or you can either run a clean build if that doesn't take too long, or you can manually delete the output file or change your inputs in a meaningless way for a given problem. But if you are going with the clean build or delete output file path, then you will run into a different problem if you have the build cache. Because the build cache doesn't care that you did the change, it will just happily go to the build cache and pull the outputs back. Which is especially problematic if you have a remote cache and suddenly there is like multiple things and you don't know like what exactly is in there. So I personally just always disable build cache temporarily when I'm dealing with Gradle debugging, because sooner or later I will run into this and it's just easier just to comment out one line. And similarly, the configuration cache applies similarly way because just for the configuration phase. If you are debugging the configuration phase, then the configuration cache will most likely skip your breakpoints. Again, disabling them is a good idea. Then fix your build, then enable it and retest again, which is important because your fix might have broken the configuration caching. And with that, here are a few closing thoughts. If you want to learn more about Gradle, I really recommend giving the Gradle documentation a try. Like, it has improved significantly since I've been learning Gradle. Nowadays, it's much more approachable for beginners. They have segments which have like estimates of how much time you need to dedicate to it. They are like structured in a way that makes sense. There are examples. There is like interactive things that you can do. And my recommendation here is that you should be proactive when trying to learn Gradle. Writing the code that you are currently reading about really helps you to remember it. And because there is just so much, anything that can help you remember things is a welcome thing. And another very powerful way to learn Gradle is to treat problems that you encounter as learning opportunities. Most people do like I did at the beginning, go to Stack Overflow, copy paste code, and have no idea what they just did. If you pause and spend a bit extra time to understand what was actually the problem, why this solution works, then you spend that amount of time now, but over time this adds up, and in the long run you will save way more time because you've encountered so many issues that you just know how to fix and how to address, that you no longer have to spend that initial time. That's all from me. Thank you for your attention. Are there any questions?